Okay, so unit 2, differentiation. Okay, remember, frame your mind around this. Everything you're doing is just finding the slope of a point. That's all we're doing. We're finding the slope of a point, and it gets really chaotic, and there's all these numbers and equations everywhere. But really, when it comes down to it, the bare bones thing that you're trying to do here is find the slope of a point or something adjacent to that, something related to that idea of slope of a point. Essential questions. You should be able to answer all of these questions now. Okay? At least, again, it might not be the best answer in the world, but in your head, as long as it makes sense, that's the main thing. So it doesn't need to be some formal answer, but in your head, hopefully we can answer these questions. Here's the breakdown. Again, we've covered everything on here already. It does not mean we perfected it, but we definitely covered it already. We just need to tighten the screws on these. You should be able to pinpoint exactly where your lack of understanding is occurring. That's the point of the group test. Basically, all of these standards are on the group test. You can figure out which section you need to work on the most. The test today, the fake test today, is also going to be similar to that. 7 questions. It's going to involve all of these standards. So 2.1 derivatives, secant lines versus tangent lines. Make sure you know the definition of this, because there are some problems where it says the secant line is defined as this. And you can't go, oh, wait, what's secant line again? It's a line based off 2 points. A tangent line is based off of 1 point. Okay. The slope of a secant line is the old school slope equation. You should know the slope, how to find slope, change in y over change in x. Now, if you make those y's get infinitesimally closer and the x's get infinitesimally closer, then you have the derivative, change in y over change in x. The rule still applies, only this time you're getting infinitesimally closer. Where this one, it could be any distance apart. It doesn't matter where the x and the x naught is for that. The alternative limit definition of derivative, just make sure you know this. This is really good for finding the derivative at a point. I highly advise not using it if you were trying to solve a problem, unless you have to, okay? Unless the problem is saying you have to use the alternate limit definition of a derivative. But again, it's still change in y over change in x. It's just now x is approaching a versus this other one where h is approaching 0, but it really is the same thing. All right, the second derivative, if you remember, the notation is kind of weird on this one, but it's like d squared y over dx squared. That means second derivative. You can also have f prime prime or y prime prime as well. It means the same thing. Okay. Second derivative. Make sure you know how to find the derivatives on your calculator. Math 8 is your friend. Make sure you know how to do it from the home screen. Make sure you know how to do it from the graphing screen with graphing the derivative and second derivative. That should already be in your calculator. And then you should know kind of what it looks like when it gets spit out. Okay. 212 is all about differentiability. If you remember, differentiability means the derivative exists at that point. Okay, it's you can take the derivative at that point. And for that to be true, it has to be continuous at that point, and the derivative has to agree on both sides of that point. You have to know that. Always check continuity first. Okay, because sometimes people check differentiability and they're like, oh, the derivative matches on both sides. But if it's a jump, it doesn't matter. It's not going to be differentiable. So it has to be continuous. And then you can check differentiability, make sure the derivative matches on both sides. If it's differentiable, it's automatically continuous. But if it's continuous, it's not necessarily differentiable. Okay. An example of that is if there was a sharp turn. So you had a graph and it's a sharp turn. This is continuous, technically. There's no holes, jumps, or gaps, but it's a sharp turn, so it's not differentiable. Okay. Now, if something was differentiable, again, it has to be continuous by default. All right, estimating derivatives at a point, super easy concept. If you can't find the derivative at a point, then use the points that are around it to estimate it. Derivative rules, make sure you understand power rule. You bring the power down and then you minus 1 from the power. Make sure you understand that. The transcendental rules as well. The ones you really have to focus on is sine and cosine. All the other ones you can figure out for trig based on knowing sine and cosine. The a to the x and the log base a of x, those derivatives, make sure you memorize those. 1 over x ln, and then a to the x itself times ln, ln. And then the derivative of e to the x is itself. The derivative of ln x is 1 over x. And then also make sure you do not forget about the inverse trig. The second you forget about it, that's when it's going to be on the test, and you're going to go, oh man, that was so easy. I just forgot about those. Okay, it's easy to forget about those. So no. Okay, product rule, quotient rule, f prime g plus g prime f for product rule, and then girlfriend prime minus f g prime over g squared. Try to memorize those by the end, please. But again, if you forget on a test, just ask. And I'll probably tell you. Chain rule, no, I will tell you unless it's the final. Okay, chain rule, I do not advise using this rule because this only works when there's one layer in there. But just remember, attack the outside layer first and then work your way in. Like think of an onion. If you were peeling back an onion, you'd start from the outside layer to go to the inside layer. If you notice, everything stays the same each time too. So you're doing the derivative of f, but g of x is still the same in here. It doesn't say f prime of g prime of x. It's still g, and then you multiply by g prime outside of it. You just keep tacking it on, multiplying it each time. And again, if you want to know where this comes from, I made that video that explains why this works, which is a really crazy video. I definitely did not come up with that algorithm to prove that, but either way, it's pretty awesome. All right, the derivative of an inverse, that's what this formula is right here. This is your home base. Okay, so if you ever forget the formula, you can always just do the derivative of both sides and solve for g prime of x, because it just uses chain rule. If you notice, I did throw it in 224, which is chain rule. I threw the inverse derivative in chain rule because it is a function within a function because of the definition of an inverse function. Remember, the f and the g cancel out to get x. Okay, derivatives of other forms of equations. So we did implicit differentiation for this one. If the y doesn't match, so say you have a function with respect to y here, you have to just take the derivative like normal, but then the rule is you multiply by dy over dx at the end of it. Okay. And explicit is when you could actually solve for y, you could isolate the y. Implicit, you cannot. Okay, so because of that, that's why you have to use implicit differentiation. So that's basically the entire unit right there. And this is all the formulas that you have to know, including, I included product rule and quotient rule and chain rule in here as well, and the inverse derivatives as well. So make sure you know all of these.